Hello and welcome to the section 7.4 lecture today. Today we're going to continue our duty of finding slope. Okay, that's our big goal for today, is to find the slope. And today we're going to try to find that slope given an equation. For starters, we're going to look at slope-intercept form. Okay, slope-intercept form is our linear equation written y equals mx plus b. And it says the slope of the line is m and the y-intercept is b. Okay, so in this example right here, we have 2x plus 3, and it says the slope is 2, the y-intercept is 3. We're not really focusing on the y-intercept yet, but that puts it right there. And kind of hard to tell on this graphic, but I do have another point right there, and it does look like it goes up 2 and over 1 for a slope of 2 over 1, which is 2. So the important thing that we get out of slope-intercept form is that the slope is the number multiplied by x. Okay, and that is the most important thing when it's in slope-intercept form, when it says y equals mx plus b, or if we can write it in y equals mx plus b. Okay, and I'm going to look at a couple of these where, yeah, it's kind of there. Some where, yeah, it's definitely slope-intercept form, and others where it's like, it's pretty close, and we can switch it into that. So that's going to be our big focus for today. Let's look at some of these examples. So in the first one, I have y equals, let's just write it above, y equals mx plus b. So m, the number multiplied by x, not including x. Okay, I have a lot of people that mistakenly will say the slope is negative 2/5 x. The x is not involved in that, but if you take that x off of there, you're right. Okay, just say less. Okay, that's probably the only time I really want you to say less, because sometimes I'm itching for you to say more. Okay, but just the slope is negative 2/5 x. Today is an identification day. It's not a whole lot of algebra. It's not what we did the last couple of days where we had to calculate the slope. It's literally find it. Okay. In the second one, what number is being multiplied by x? There's a minus sign there. So what number is being multiplied by x? Well, I can rewrite this to say negative 1x minus 2, and that helps a lot of students a lot more. Now, I do like to see slope written as a fraction, and any whole number can be written as a fraction if you put it over 1. Just because when we go to graphing our slope, it's a little bit easier to know that that's negative 1 over 1. So I have my two directions involved there. If I just say that it's negative 1, I get a lot of people making mistakes there. Now, if we were just coming up with an answer, I'm okay with negative 1. But we want to think of that as negative 1 over 1. Okay. And I just bring that up because most of the time, like when I'm coming up with multiple choice answers, I'm not going to strictly put negative 1 over 1. I would put negative 1 on there. Okay, but I want us to be thinking that that's negative 1 over 1. In these last two here in this section, I have, it's kind of slope-intercept form in that it's solved for y, but it doesn't have the numbers in the right order. I can rewrite them in the right order by just switching these two in their places. The trick when I switch any numbers, when I switch anything around, is that I keep the signs attached to the numbers. That's a positive 5 and a positive 2x. I don't want to just think about moving them around because sometimes that could make us make mistakes. But if you pull the sign with the number, you're never going to make a mistake. Okay? In that, what we're really doing here is called commutative property, and it works with addition, but it doesn't work with subtraction. The only time it does work with subtraction is if I pull that minus sign with the number that I'm moving. That doesn't show up in this one, so I can just write it as y equals 2x plus 5. But I just want you to think about that positive sign is in front of the 2x, and this positive sign is in front of the 5. And now it's relatively easy, and it's not going to change our answer at all, even though we technically think that we have to rewrite this. It's still the number that's multiplied by x that I'm looking for. So you don't really need to switch it around. Okay, but that is still a good thing to do if we say that we're using slope-intercept form. Okay, so in this next one, it does come up that if I do want to switch it around and write it in true slope-intercept form, I do need to pull the signs with the numbers. The 13 is positive and then 1/8 x is negative. So if I do switch that around, it's going to end up being negative 1/8 x plus 13. Now I know there's a plus sign here. There wasn't a plus sign anywhere in this problem. That's because it was hidden in front of the 13. Okay. When you do that, you can switch it around. When you pull that negative with that 1/8, you can switch this around, even though we've been taught for years that subtraction is not commutative. We're not really commuting subtraction. We're saying that this is actually plus a negative 1/8 x, and then we have addition here, and we can switch the two locations. Okay, and again, even though I like to do this so that it looks right, it's not going to change my answer. My slope is negative 1/8. My slope is negative 1/8. So in the given problem, before I put a bunch of marks on there, the slope is still the number that's multiplied by x, okay, without the x, but with the sign that's in front of it. Okay. Apparently I have two options here. When we're looking at standard form, this is another type of equation of a line. And it's called standard form, and that at one point somebody wanted this to be kind of the end-all be-all of line equations. They wanted this to be the marquee equation. When in all reality, it's probably the hardest line form that we will ever deal with, being that it doesn't give us anything cool like slope-intercept form. Gives me my slope and gives me my y-intercept right off the bat. I don't have to work for it. I just have to identify it. And in standard form, it's not as easy. They don't give me hardly anything. They just give me that x and y are on the same side, they equal a number, they're being added or subtracted, that kind of thing, and that there's numbers attached to them. And I really think of two methods to do this. Okay, number one is turn it into slope-intercept form. I'm just going to write y equals mx plus b. That's one method. Okay, and we're going to look at that first before we look at the second method. And so what that involves is that just involves solving the equation for y. Sometimes that's easy, sometimes it's not. Okay. In this first one, I would want to subtract 2x. My goal is to get y by itself. So I'm going to subtract 2x from both sides. And so if I subtract 2x, I still have this negative on the y. And that's going to equal, the negative 2x and the 5 can't really combine. There's nothing I can do to bring those together at all, so it's just negative 2x plus 5. And then I have to deal with this negative on the y. I'll deal with that by dividing everything by negative 1. Okay, dividing something by negative 1 just switches its sign. Negative 2x divided by negative 1 is just 2x. Positive 5 divided by negative 1 is negative 5. And now that it's in slope-intercept form, it's an identification problem. My slope is equal to 2, the number that's multiplied by x. Now, I wish I had the same problem over here. That would have made life a little bit easier. But let's do a couple more this way and then see if we can see a pattern. Okay, maybe we'll do one more this way. How's that sound? So I'll do the same thing here. I want to solve it for y. I want to get y by itself. So I'm going to subtract the 3x. And then I get 5y equals negative 3x plus 10. And then I'm going to divide everything by the number multiplied by y, which is the same thing I did up above, but the number multiplied by y was just negative 1. And when I do that, I'm going to get y equals negative, I'm going to write that as negative 3/5 x rather than negative 3x over 5. You can do that at any point. That's an easy move. And then 10 divided by 5 is 2. Now for the number multiplied by x, it's just negative 3 over 5. So in the world of standard form, the one thing that we love to do is realize that when we start using standard form, we're doing the same, whatever we try to do. So here our goal was to turn it into slope-intercept form. We do the same thing every time. We move the x term, and then we divide by whatever's multiplied by y. We did the same thing here. We moved the x term using addition or subtraction, and then divided by whatever was multiplied by y. And so what that turns out to be is for my slope. So everybody wants to come up with shortcuts when we deal with the standard form, and you can do this if you want to because it is a shortcut. You'll see how it's a shortcut in just a minute. But I still think that you should, if you can do this method, then stick with this method. If this works for you, do it every time. Don't pay attention to what I'm about to say. But if you have a good memory, there's a quick way to figure it out. Notice in this first one, my slope was 2. And in the second one, my slope was negative 3 over 5. And I have a 2 or a 2 over 1. And I have a 3 and a 5 for my 3 and 5 that are here. But the same thing happens every time. When I move the x term over, because slope comes from the number multiplied by x, it's somehow involved, right? 2 is somehow involved, and 3 is somehow involved. It ends up being the numerator of each one of these fractions. In a way, it's the opposite of it, because when I move it over, I'm doing whatever sign is on that number multiplied by x, I'm doing the opposite. On these two, they were both positive x terms, and so I subtracted them. So the quick way is to say that it's the negative of the number multiplied by x, which in standard form we call that a. And then it's always divided by the number that's multiplied by y, which we call capital B. Okay. Now this takes memorization, but this is as hard as you have to work to find the slope using this method. You have to remember that it goes ax plus by equals c. And the slope is going to come from the opposite of the number multiplied by x divided by the number multiplied by y. If we check that in these two, the opposite of 2 is negative 2. The number multiplied by y is negative 1, and negative 2 over negative 1 is 2. In this one, we're going to get the exact same thing. The number multiplied by x is 3, so I use negative 3 over the number multiplied by y is 5. Negative 3 over 5 is the same thing that I got here. So if I use this shortcut, I can just say that my slope, opposite of the number multiplied by x. Well, there's nothing multiplied by x unless you consider that to be a 1, okay, which is what it is. So I have negative 1 over the number multiplied by y, which is 3. So this can be a shortcut, even though I've talked about it a lot. Shortcuts always come from making assumptions based on doing something multiple times. Okay, on this one, the number multiplied by x is 7, so I want negative 7. The number multiplied by y is negative 3. Negative 7 over negative 3 is the same as 7 over 3. Okay. So those are the two normal equations of lines. We can be given any equation of a line. As long as an equation has an x and a y, it represents a line. So if we're given any random equation, our main thought is to turn it into y equals mx plus b. Just like option 1 from the previous section. So that's still a good method. And you know, it's basically solving equations. For this one, I'm going to try to get y by itself. I'm going to add 8 to both sides. And so I get 5x plus 8 is equal to negative 4y. From there, I'll divide by the number multiplied by y. Divide everything by that number multiplied by y. And this looks a little bit odd. I'm going to say negative 5 over 4x. Oops, that's going to be a minus. 8 divided by negative 4. Yeah, 8 divided by negative 4 is negative 2. And then y is by itself. If you want to switch sides of the equal sign at any point, you can do that without any work. Just do it. Say y equals negative 5 over 4x minus 2. So my slope is negative 5 over 4. On the next one, I want to get y by itself. That shouldn't be too bad. There's only one number on y's side. I'll subtract 1 on both sides. Y equals negative 1. Now that's tough because there's no x involved. Well, what that really means is that we have a 0x minus 1. 0x now puts a number multiplied by y. Sorry, it puts a number multiplied by x. And we get the slope is 0. If we don't have an x in an equation, that means the number in front of it had to be 0 to make it go away. Okay. This next one is technically standard form, right? X and y are on the same side. They're being added or subtracted, and they equal a number. I'm not going to treat it like it's standard form because it looks simple enough that I can just subtract x on both sides. And I'm going to get on the left side, let's call it negative x plus 1, and that equals y. To make things feel a little better, I'll switch the sides of the equal sign and just write y equals negative x plus 1. The biggest thing I want you to feel comfortable out of this class is the idea of moving things around. Okay, that's a huge skill to have in any math class. And then what number is being multiplied by x? Well, it's a negative. Negative what? Negative 1. And there we go. Last but not least, we've got just an ugly form. It's no specific line form, but my goal is the same. Get y by itself. 3x minus 4 and divide everything by -2. Okay, here I get y is equal to 3 over -2, I'll write as -3 over 2 times x. That would be +2, but that part doesn't really matter. What I do care about is the number multiplied by x. My slope is -3/2. All right, and that'll be it for today. Make sure you get any questions you have over on the left. Make sure you're turning in the question assignment that is this video. Those are counting for points in this class this term. Just a little incentive to get you to watch the video and give you a place to throw those questions that you have, because I know that I'm not the best at always asking right when we get into class. Anyways, I hope you have a great day, and we will see you in class.